Welcome to Math with EJD. Still talking about partial differential equations. In this video, our focus is on applications of first order PDEs. So first, an overview of that. First order partial differential equations are foundational in several areas of applied mathematics, physics, engineering, and economics. Economics. They are often used to describe systems that evolve over time and space, especially where the behavior is governed by a single characteristic variable or process. Okay, so below are key applications along with their relevant equations. So let's see some applications, right? Um, applications, application areas. First of all, we have first order partial differential equations in fluid dynamics. Of course, fluid flow takes place in time and space. That's why it has to be it has to be represented by a partial differential equation. So, for instance, first order PDEs, first order PDEs, say that applications of first order applications of first order PDEs. So first order PDEs, right? First order PDEs such as the Burger's equation, the Burger's equation describe the motion of fluid flows. The motion of fluid flows, especially when shock waves or other discontinuities form or other discontinuities form. This equation is used in compressible fluid dynamics. Compressible fluid dynamics. And this is it here. You have u of t, ut plus ux equals 0. Now it looks to me like it's something like a quasi linear differential equation. Of course, I hope you already know that it's the same thing as partial u, partial t, plus partial u, partial x equals 0. It's exactly the same thing as this. Okay, so that's the Burger's equation. So Then we go for another application. Number two, application of first order partial differential equations. We have what we have traffic flow. Okay. So traffic flow. So it's a flow, right? And it also takes place in time and space. So traffic flow theory, in traffic flow theory, the light hill, there's a light hill Witham, light hill Witham, light hill Witham Richards, light hill Witham Richards. That's the LWR model. Okay, uses a first order. This is a first order partial differential equation to describe how traffic density, how traffic density evolves over time and space. The model is given by partial rho partial t plus partial x into partial x into rho v of rho equals 0. Okay, let me do that better. So partial rho partial t plus partial x into rho v of rho equals 0. So that is the, okay, of course, this is the Berger's equation. Now that is the uh, light hill with Richards traffic model. Okay. Then we go for the third one, which is something about acoustics and wave propagation. So first order partial differential equations also appear in the study of wave propagation, such as in acoustics. Acoustics talks about sounds, right? Such as in acoustics. The propagation the propagation of sound waves in a medium can be modeled by a first order partial differential equation along the characteristics, which is partial u partial t plus c partial u partial x equals 0. So this is something about acoustics. Of course, you know, it's the same thing as u sub t plus c u sub x equals 0. Exactly the same thing. Then we go for the fourth one, I think. Yeah, the fourth. So we also have this in economics and finance. In fact, the kind of, to be a chartered financial analyst, for instance, you need to deal with a lot of serious partial differential equations. So in optimal control theory, particularly in finance, first order PDEs are used to model the evolution of financial variables. Of course, there we're talking about option pricing, hedging, and the rest of them. Evolution of financial variables over time. Okay. The Hamiltonian, the Hamilton rather, the Hamilton Jacobi Bellman, Hamilton Jacobi Bellman, HJB equation is a key equation in optimal portfolio selection. Optimal portfolio selection given by partial V, partial T plus the minimum across U of think this should be LUV equals 0. Of course, since you're not delving into this, I'm not talking about what each of these terms mean. But of course, if you're interested, you can investigate further into these things. So number five, we have image processing. Image processing is another area of application of first order partial differential equations. Image processing. So for image processing, okay, in image segmentation, in image segmentation and enhancement, first order PDEs can be used to detect edges or partition an image into different regions. Okay, so that throws up the Mumford-Shah model for image segmentation. So the Mumford-Shah model for image segmentation can be formulated as E of U equals integral across the space or curve nabla U, absolute value of nabla U plus integral across another one, that's lambda of x ds. Okay, this is the Mumford-Shah model for image processing. Okay, then we also have another one, that's number 6 now. Number 6. So for number 6, we have what we know as geophysics. Interestingly, today seems to be the World Geophysical Day or something like that. So geophysics, so in geophysics, first order geophysics, the first order PDs model the propagation of seismic waves through the Earth's crust. Okay, and then the aconal equation, a fundamental first order PDE, governs the travel time of seismic waves. So in a place like Japan where we have earthquakes a lot, this concept, this kind of equation is something that should be investigated a lot. So we have nabla T of X, absolute value of nabla T of X equals 1 all over V of X. So again, I'm not talking about the parameter, the terms involved, but of course, this is an introduction to it. So if you may want to check what the equinal equation is about, so you can get more ideas. So we see that these examples illustrate the versatility of first order uh, first order PDs across a wide range of disciplines, whether modeling the flow of fluids, the movement of traffic, the propagation of sound, or the dynamics of financial systems. First order PDs provide essential insights into the underlying processes and systems. I feel that is important to write, right? So let's go for that. So this conclusion, okay, these examples, there are many more, of course. These examples illustrate the versatility, the versatility of first order PDs across a wide range of disciplines. Okay, whether modeling the flow of fluids, the movement of traffic, the propagation of sound, or the dynamics of financial systems. First order PDs provide essential insights into the underlying processes and systems. Okay, so with that, we come to the end of this video. So you can see the wide-ranging application of first order partial differential equations. So let me know in the comment section how helpful this video is for you. And of course, feel free to let me know if there's a topic you'd like me to teach or a problem you'd like me to solve. I may be able to find time along the line to do all of that. And if you have subscribed to this channel, thank you. If you have not, please go ahead and do that right now. And remember also to hit the notification bell so you can always get alerted each time a new video is released. And be sure to like and share also so that more people can have access to this great content we have right here. There's so much to learn, so much, many playlists there for your learning. Till I come your way again, keep doing maths right. Bye.